Here's 8-67 for integrated 3. So this one says for each set of points given below, write a possible equation of a quadratic function in standard form. So I think we just talked about this one. So these are actually the intercepts of the quadratic. Like if I wanted to see what this parabola looked like, I would see that it's kind of like this. Okay, those are the intercepts. So I can use that method where I just go, it's just x minus 3/4 times x minus -2, which would be x plus 2. Yeah, I could write it as equals 0 if I want. Okay, so then all I have to do is just multiply this out. So I don't know, I guess we can just use like an area model, or you can use FOIL if you know how to do that. So x minus 3/4 times x plus 2. Because we're doing this because we have to get it into standard form. So that gives me x squared minus 3/4 x. This gives me 2x, and this gives me 2 times negative 3/4. Well, that would be negative 6/4, but that's really the same as 3/2 negative. Or you can think of a cancellation. Okay, so then that I can write that as x squared. What's 2 plus negative 3/4 if I do fraction math? Well, this would be 8/4 minus 3/4, so that's 5/4. So we're probably going to want to change that a little bit, but we'll leave it as 5/4. So I wrote it like this, but I know that if I just multiply everything by 4, that'll get the fractions to go away. So I can say this could be 4x squared plus 5x, and then if I multiply this by 4, I think minus 6. So let's see which one your answer key. Yeah. So your answer key keeps doing it like this. Like whatever fractions you get, you go ahead and do the fraction busting or whatever. Okay. Now this one's going to be a little bit different, this one over here, because they're just saying get a possible equation of a quadratic. So if I just simply do the same thing as I did on this one with this one, I would have to test and make sure the negative 3/12 actually is on the graph. And then if it's not, I would have to find a stretch factor for it. This one I didn't have to worry about any extra points. It just gave me these two intercepts. I noticed these two, since there's zeros here for the y, those are intercepts. So these are the solutions. So I can kind of do it the way I did this one. I can go, this will be x minus negative root 5, which is x plus root 5. And then this will give me x minus root 5. But then I don't really know if these are going to be on the graph. So I'm going to go ahead and just put an A for a stretch factor. And then I'm going to plug this x and y in there. And if A turns out to be 1, I'll know that I probably didn't even have to do all that hard work, because maybe those already were on the graph, but I have a feeling they're not on the graph. So I'm going to go ahead and plug in for x. I'm going to plug in negative 3. And this isn't really, this is, it's going to be kind of some hard work because we have square root 5. So I don't know if we're going to end up using some decimals or what we're going to do here, but negative 3 minus square root 5. And then this is A, and then this is 12. So, I don't know, I'm supposed to multiply these two to, well, I don't know, I guess I can multiply them together like this. So negative root 5 times root 5 would be negative 5. These cancel out, and 9 minus 5 is 4. So it turns out that all that ends up just being 4. So now I've got 12 equals 4 times A. So A must be 3. So 3 equals A. And then, so what is my equation? Well, yuck. So y equals 3 times x plus root 5 times x minus root 5. So this part is just x squared minus 5. X squared minus 5. And then it's, well, so that's something like that maybe. Let's see if that's right. Yes. So those are good questions.